Okay, so we are continuing to work on our card matching game. We started the class today by actually adding a new class to our model, the card matching game class. Here's the definition, and as you can see, we have a fairly simple class. We have the constructor, and the constructor takes two parameters. A count, so how many, that's a card count, how many cards are in the game, how many cards are we going to deal face down to play with, and the deck that we're going to take the cards from. And again, notice it's a deck, not a playing card deck. So it's a pointer to the base class, but what we are going to do is hand in the derived class, so the same game object could be used with multiple derived classes. There's only two methods. One is choose card at index. So we have count cards, and we're going to put them in a vector and keep track of them so we can identify them by index into that vector. So I can choose a card at a specific index, and depending on the current state of the game, choosing that card could do different things. If that card was currently face down, choosing it would turn it face up. If it was currently face up, choosing it would turn it face down. And when I do turn it face up, when I choose a card, if there's another card that's face up, I'm going to try and match them. And if I do match them, I'll get some points for matching them. And if they don't match, then maybe I'll lose some points as a penalty. And that's the game logic, and we're going to work on that later. Okay, the second method that we're adding is get card at index, and that's going to return a card pointer to that card. And that's primarily going to be used by the controller in its draw method. So when after the user has changed the game state by choosing a card, we're going to want to redraw the game. So we're going to have to go through all the buttons and decide what to draw for each one based on the contents of that card. So we need a pointer to the card to be able to query the card to ask whether it's currently face up or face down, or if it's been matched, we're going to eventually gray it out or do something to indicate that the card's matched and is no longer in play. We're going to have some private members, some state. We're going to maintain the count as part of the state. I guess technically we don't really have to do that because the count will always be, after the constructor is run anyways, the count will always be the size of the hand. So if I have count, it tells me how many cards to deal. So when I construct the game, I pass in a count of 10, that means I'm going to deal 10 cards into my hand. But just for convenience, we're going to have it as a separate member. So, and I'm also going to have a hand, which is going to be a vector of card pointers. Again, the base type, not the derived type. And in my constructor, I'm going to deal cards into the hand from the deck. And we're going to have a score, because it's a game, and we want to keep score. Okay, so that is our definition file, and now we'll just quickly look at the implementation of some of those things. So for each of these, I'm doing an assert at the beginning of the method. And we talked about assert in class. It's just making sure that the count that is being passed in is reasonable. So in the case of the constructor, I want to make sure that the count is, I'm passing into the constructor a count and a deck of cards. And I want to make sure the count is less than or equal to the size of the deck of cards. I don't want somebody to hand me a deck of 52 cards and tell me to deal 100 cards. That's going to cause a problem. So rather than cause a hard-to-find problem down the road somewhere, I'm just going to put an assert here. And if that does happen, it's going to crash the system, hopefully in testing, and I'll find out about it before I ship. So once I've asserted that the count is less than the size of the deck, I just deal count cards from the deck using draw random card and put them into my hand using pushback. So I'm just adding these, and remember, draw random card returns a smart pointer to the card. So I have a hand is a vector of smart pointers to card objects. Okay, the next one we did was this one here, get carded index, just because it's simple. So again, we're going to assert that the index is less than count. So if you're asking me for a card at index 5 and there's only 5 cards, remember indexes go from 0 to 4 if I have 5 cards, that's a problem. If I go ahead and try and return the card at that index, it's going to cause a crash because I've run off the end, or potentially because I've run off the end of the vector. So I'm going to first make sure that the index you're asking for is valid, and then all I do, it's very simple, it's one line, just return the card pointer stored at that index in the vector. And then most of the meat of this class is in the choose card at index. And depending on the state of the game, different things are going to happen. If you choose a card, okay, and again, we're going to assert that the index you're asking for is less than the count. And then I have a temporary variable which holds a smart pointer to a card. I'm just going to grab that pointer out of the hand using get carded index so that I can put it in this temporary variable and work with it. So the first thing I'm going to do is say, if it's matched, I'm just going to return. If you choose a card that's already matched, once they're matched, they're out of play. I'm not going to turn it over. I'm not going to try and match it again. And I'm not going to count it towards your score. I'm just going to return. If you choose a card that's chosen, so we've already returned if it's matched, so you're clicking on a card that's chosen, which means it's face up. And when you click on a card that's face up, we turn it face down, so you're just turning it back over. And so all I have to do, the state of the card then is chosen as false. So if the state of the card is chosen as true, among other things, that means it's going to be face up. And if it's false, it's face down. So all I have to do in my model is just change the state of the card. Later in the UI is going to decide what to draw based on the state of the card. But we're in the model here, so all we're doing is changing the state of the card. And otherwise, so if the card is currently not chosen, it's face down. If I choose it, for now, all I'm going to do is set chosen to true, which means in the model, it should be face up. And I've put some comments here that we're going to do a bunch of other stuff. Game logic is going to go here. So what that game logic is going to be is I'm going to have to look through my model for other cards that are chosen but not matched, so other cards that are face up. And then remember we had a discussion that it's the derived card, the playing card, that knows if it's a match to another card. So I'll have a matched or test for match or some sort of a method on the playing card, which we haven't implemented yet, that looks to see if it is matched to the card that we just chose. And that's going to return, it's going to return an integer because there's going to be a score associated with that. So for instance, I might have a higher score for matching rank than for matching suit. You could match it by suit or by rank, and you get more points if you match rank, because I think that's harder to do than matching suit. But anyways, that's game logic, and we'll talk about that later. For now, we're just implementing enough of our game class so that we can go back and integrate it with the UI. So that's it for what we did in the game class today. And now we also made some changes in the controller. And this was kind of a big thing. What we did was in the form, we removed before we did drag and drop and put a button on the form, put a frame on the form and put the button inside the frame. And then the user interface compiler generated some C++ code, which we looked at in the UI_main control.h file, which is in the build directory. It's a build artifact. It's generated from the XML for the form. And we looked at it to see what the syntax looked like for creating a button. And we used that, and we also looked at the help for push button to see what we have to do. So the first thing we did was instantiate a push button. So we have this new variable we're creating in the constructor here. It's btn, which is a pointer to a QPushButton, and we instantiate a QPushButton with new QPushButton, and we pass it a pointer to the central widget because it's like other Q objects and Q widgets. We pass a pointer to the widget that's going to own it and manage its memory, and also be responsible for drawing it. Now, we did that first without setting any of the maximum, minimum size, font, or any of that stuff, and we saw the button did appear. It was all squished up, and then it didn't look like a card and wasn't great. So the next thing we did was we created this font object that we're going to use to set the font. We took our button object and we set the minimum and maximum size to essentially force it to be a fixed size. We set the font using the font object that we just created to give these characteristics to the font. So we set a point size, we set it to bold, we set a weight. And then we set, this is the same style sheet that we used previously for our UI button. We used to set our new button, and we set the text to blank. And having done that, our button displays, and it looks like we want it to. It's the right size, and it has the right image drawn. And then the next thing we did was, now we've created our own button, and it no longer has the same name as the button on the form did. So the button on the form generated a slot for us based on the name of the button on the form, which was automatically connected for us by the mock compiler. That's one of the pre-compilers that generates code. That's not going to work anymore because we don't have a button on the form, we have a button we created, so we're going to manually connect our button to our slot. And because our slot was named based on the name of that button that we on the form that doesn't exist anymore, we're going to rename the slot. And we're going to use this one slot. We're going to connect it eventually to all of our buttons. So no matter what button you click on, it's going to be connected to run this slot function. So we renamed it to onCardButtonClicked. And that has to happen in the .h as well as the .cpp. And then we can do our connect statement. So connect takes 4 parameters. The first 2 parameters are a pointer to the object and a function pointer to the method in that object. That's the signal to the object and the signal that the object emits. So in this case, it's a QPushButtonClicked signal that it can emit. So that's just a function on the QPushButton object or class. And then the second 2 parameters are the object where the slot exists and the function pointer to the slot. And then remember, this is in the constructor, so this is a pointer to the object that we're constructing, which is where that slot exists. And the name of the slot function is onCardButtonClicked, and so we do ampersand to take the address of that function, and it has to be fully scoped, so it's main control onCardButtonClicked. and that is a function pointer to the onCardButton clicked method. The next thing we did was come down and look at it. We had commented that all out to get it to compile, and when we uncomment it, we see we still have a problem. And the problem is, in the slot here, we're referring to the button through this UI pointer, and that's no longer valid because we took the button off of the form. That's the way we get to those things that were generated in the form. And the problem we notice is we create this button pointer in our constructor, but we didn't save that pointer anywhere. So what we did in class, the last thing we did in class was in mainControl.h, we added a vector rather than just, we could have, for right now, added a single member that's a push button pointer, but eventually we're going to have more than one card. So better to have a vector of push button pointers, because we're going to get there eventually anyways. So we have this member underscore card buttons, which is a vector of pointers to ourQPushButton objects. And so now that's some state that we save in the main controller object, so I can refer to it later in the main controller object. So we've defined this card buttons is a vector of push button objects. And what we're going to want to do is, after we create this button and set all the settings for it, we're just going to put it in that vector. So push back the button. And for right now, in this example, we only have one button, so it may seem a bit silly to have a vector for one button, but as I said, eventually, or tomorrow, next class, we're going to have several buttons. And your homework was to do this, and then to change the slot so that it uses the button pointer that we saved here. Now we have this card buttons vector, which is going to have count pointers to buttons, and in our game we have a hand vector which has count pointers to cards. So we have a relationship. In our game we have a hand of count cards, and the index into the array represents a specific card. And likewise, we have a vector of buttons, so the index into the vector of buttons is going to be how we display the information in the UI about the object in our model at that same index. But for now, all you have to do is modify this slot on card button clicked to use this pointer up here, and then when you've done that, you should have a single card that displays like this, and I haven't connected it yet, so mine's not flipping, but you should be able to, once that slot's connected, click on the card and have it turned over and display a random card, and back and forth between the back of the card, and each time you turn it over, it should be a different random card. Okay, and that was it for what we did in class today and our homework for next class.